welcome to my first video. And today I want to show you, so maybe you are interested in electronics and you just found something like this on the side of the road and you want to get some parts from it. So here is what I think the most efficient way to take apart a TV like this is, and what the different parts are and what you can use them for. First, we need to take it apart. So, here is the back. You see it's one of the older ones. It just has a 75 ohm antenna cable thing. You can hook that up to a Atari like we've done with that TV over there. But here, it is a 755-69412. It doesn't say the year back here, but up here it says 1.8 amps, 60 hertz, under 20 volts, which would mean the power consumption would be around 210 watts, which is unusual. Like, I've seen one maybe twice the size of this that had 110 watts. But yeah, let's take it apart. So this screw, you notice, it is a hexagon shaped head. But don't be worried if you don't have one, because this is rare. See, I'm using a screwdriver. Because usually they use star head, Phillips head, or flat head. I've never personally come across a flat head, but one TV or another should use it. This is tough. It's just because of rusty screws, or they're not working hard enough. I've taken a couple more screws off, but let me tell you, this is not the most efficient way. I find the most efficient way is to tip it over. Screws, yeah, 2 more screws now. There's the last screw. And here comes my favorite part, the moment of truth. Now, you'll be left with something like this. This panel here isn't always there, but there is a treasure behind it. And if we look down from the side here, you see this heat sink. What's behind it is really the treasure. Then, down there is the flyback transformer. This is the real treasure of these TVs. You can tell how old it is because of the gap between the core and the resin and plastic block. That, its maximum output, from my experience, seems to be around 150,000 volts. But now to the rest of it. Up here, you're going to find this little tube board. And if you wiggle it a bit, it should pop loose. But if it doesn't, don't keep doing it, or else this will happen to you. You come over to this TV, try to take off the tube board, and whoopsies. You gotta be careful not to break this glass, because there's a high vacuum under it, and if you break too large of an amount of it, it will go. You don't want to be that guy. But then onto the stuff on this board. You have these little ICs, which I've never really taken off because I haven't thought that they're really useful. But now that I look at them, some might be dual transistors. So I need to check those out. Then you're going to have this capacitor here, which in this case, yeah, it's rated for 2 kilovolts. That's its usual rating. This one over here, see what's it rated for? 22 microfarads, 250 volts. can use those to repair fluorescent bulbs, if you find one like that, of course. Now, the vacuum tube, if you take that off, and then take yeah. Okay, it's out. Clip comes off. Now, you wiggle this a bit. This starts to come off, but you need to cut these wires first. You don't need to, but it's real pain in the butt to unplug them from the board. Then this will just slide off. This is the deflection coils. You can see there's some nice wire in here. Then you have the ferrite and wire. If I get this ferrite off and keep the windings on, I found that it gives me about 5 or 6 kV at a decent current. So that's great for powering fluorescent bulbs. Then let's move on to the circuit board. First of all, this power cord. You can never have enough of those. So, time to take this panel off. And I hate when they clip the wires on like that. Now, the circuit board usually is too stubborn to just slide out. Oh, see, like this one. Sometimes if you unplug a couple things, it will pretty easily. But I've had some TVs like this computer monitor. It wouldn't come out until I took out the tube and took out a ton of screws and broke a ton of plastic. And finally the moment of truth came. Now let's try getting it out. Okay, that didn't work. Okay, then you have this little thing. This is full of copper wire. Don't know an exact use for that, but been experimenting a couple things with it. You might be wondering, well, if the flyback is on the heatsink, what other treasures lie behind the camera's field of view? Well, let me answer your question with the biggest transistor you've seen in your career of an electronics hobbyist. That transistor is ginormous. I love it. Okay, board's out. And here's the transistor I was talking about. That one, I've used those a lot. Sometimes they only handle like 9 amps. Usually the ICs on this aren't really worth much, in terms of electronics, of course. This, if you see something sort of suspicious looking like this, which looks like it may be some astable chip, feel free, but mostly these ones are EPROMs. Then, like this, it's the TDA A7052B. There's 2 of them. Those often are audio amplifiers. These microcontrollers are not usually worth salvaging. But over here, we have this giant capacitor. I always take those. Then this transformer, which is most of the time only really useful for rewinding, but if your flyback is terrible and only outputs like 1000 volts, no matter what driver you use, then definitely take that, because with the right driver, this outputs like 15,000 volts. But anyway, this flyback, it's actually pretty good condition. But along with that, you have this little choke here, which looks like it might just be an ordinary inductor, but I think it's just a choke. Actually, is that a transformer? Yeah, I think that is a transformer. But then you also have these high wattage resistors right here. This one says 10 watts. Looks like it says 1 ohms, but I don't really know. Then you have a choke. This relay is pretty useful. Then you have all these little buttons. Sometimes they have an LED. Never a time when these aren't useful. Then an infrared sensor, which you can use with some of the other stuff from this to maybe make a magnetic levitator. Well, if you have the TV remote, you should be able to. But over here, we have big capacitor. This one, those ones are usually rated at 0.22 microfarads and anywhere from like 125 to 275 volts. Though I've pushed them to higher voltages, but they're not as tolerant as like these little ceramic guys. Those ones can be pushed way beyond their limits because these ones start to inflate and pop. So don't use those for very high voltages. Just use them for like input filtering, like it's used here. Sometimes they come with this annoying plastic frame. So you either need to take out some screws to get it off, or you just do it the way that I do it. Grab some tool like portable vice grip and rip it off like a man. But of course, I didn't get every of these little plug guys, so I need to get them off. Let's see, anything else? It should come off now. So separate. Wait, what? Oh, stupid plastic clip. Hate these little things. Cost me a lot of time. Fortunately, no money. Let's see. There. Whew. I completely forgot about the flyback. Now I'm gonna get the flyback leads. But I would recommend not cutting this red wire at a short length. I'd recommend getting a flathead screwdriver like this one, then going over. So to pop off this lead from here, it's pretty simple. Just want to stick a screwdriver under, then try and force it into the center, get it under, and then, that's never happened. Well, you get it off like that. Then you have these metal prongs. If you want, which I usually do, but I've stopped doing it, is cut it off right there and then strip it down. But, yeah. Now, see you in a bit after I desolder some components. Now, my big transistor is almost out. It's also called the horizontal output transistor. And here she is, boys and girls. I'll tell you the part number in a bit. So here, the flyback, doing a bit of work on it. Having trouble getting all the solder off. So here's some of the components I got. Unfortunately, I wasn't able to take the flyback off because they have these little metal rings that keep a lot of the solder on. But here's what I did get. Here's the horizontal output transistor. It is a 610597. Then there's this IC. I'm almost certain it's like an operational amplifier or some audio amplifier IC. Then 3 big electrolytics. There's 100 microfarads, 200 volts, 250 volts, 47 microfarad, 200 volts, and 680 microfarad. I like these big caps, especially like I've been trying to make some inverters recently, like with the Royer oscillator and maybe fine-tuning the frequency. But I don't have a transformer with a center tap primary. But also, when I made a Joule Thief inverter, then I wanted to use these capacitors to smooth out the output. And then I tried one. Sort of worked, except my inverter output was sort of going on and off randomly. It sort of kind of charged the phone, except it didn't. But, yeah, at least it outputted something. So, there's still a bit more stuff, like this board. You have the tube, which there's not much you can do with it. You have the 2 speakers. But you can reactivate the tube. But, so what you need to do is first use your multimeter, not multipeter, on the resistance setting, or I would preferably use the diode test setting if you have it. But this is my multimeter. You'll want to set it to 200 ohms. Then just set it down somewhere. I'll put it here. Then let's start testing these different pins. It's usually over on this side. Okay, have a better angle at it. Oh, yep, there we go. So those 2 pins. That is the heater. So you're going to want to put a current limiting resistor there, hook it up to your power supply, and then attach a flyback. At this electronic swap meet, I did find this pulse generator from the 50s or 60s. Still works, but the cord was cut, so I fixed that. It's turned out to be really handy. But if you power a flyback, you just attach one lead to here, another lead to these different pins until a dot appears on the screen. Then when you do, you can reattach the deflection coils, get 2 bipolar transistors and 2 potentiometers, attach the potentiometers to the positive supply, and then adjust to the base of the transistors. Then attach the collector to one end of each deflection coil set, and then the emitter obviously to ground, then the other end of the deflection coils to positive. Then you can move the position of the dot. And yeah, like I said earlier, you could use this as a fluorescent bulb power source, or you could use it for the magnetic levitator thing. But I would definitely prefer using these to create a toroidal transformer.